For a very long time, Titan was considered the second largest moon in the solar system. Only when new advanced telescopes capable of seeing farther were pointed at Jupiter and examined its specifics did we realize how massive Titan truly is and gave it the title of the most giant moon. So in that time when it was thought of as second, it was in first place. The position belonged to the giant named Ganymede back in the early 1600s. Some brilliant minds figured out ways to enhance their own vision. Thanks to these newly invented lenses, at first they didn't have much use for the everyday townspeople making a modest living. But when the greater minds started using them, a new era was formed. After Galileo Galilei looked through one at Jupiter and discovered its 4 moons, the conception of the world changed. Previously, we only knew of one natural satellite of Earth, the moon. Now, other planets also had their own natural satellites. This led to a rather explosive new interest in the satellites of other bodies in the solar system. On March 25, 1655, the eminent Dutch scientist Christiaan Huygens pointed his telescope to the skies and looked at Saturn, the farthest planet that science at the time was able to detect. On that fateful day, Huygens not only saw Saturn's beautiful ring system, but also several gigantic moons orbiting a giant planet. And from then on we had Titan. Titan was the first natural satellite discovered after Galileo Galilei found the 4 moons of Jupiter, marking the 6th moon humans were able to find in the sky. At first, this moon didn't have the majestic name it holds today. Huygens simply called it Saturn's moon, Luna Saturni. It wasn't until the end of the 17th century when astronomers discovered more moons around Saturn that we needed a proper name for it. Initially, the common naming convention used by scientists would have temple, so Titan would have been named Saturn V. But this would surely cause confusion down the road, as Titan is clearly the 21st moon and not the 6th. So numbered over and into further difficulties as we discover more and more moons. In 1847, the astronomer John Herschel published the results of his astronomical observations recorded between 1834 and 1838 at the Cape of Good Hope. In these notes we see the familiar names of sky deities, specifically Titans from mythology, assigned to Saturn's moons. And from then the name Titan was reserved for Huygens' moon. Through telescope observation, we know the orbital period of the moon around its planet. By recording this cycle, we can calculate how long its orbit lasts. For Titan, it takes 15 days and 22 hours to complete one revolution around Saturn. Titan has an interesting similarity between Earth's moon and some other large moons of the solar system in that they are terribly locked to their planet. This means one side perpetually faces the planet. This leads to great variance in the weather conditions compared to our planet, who raises questions about what existence on such a moon would be like. However, despite great curiosity about its traits, scientists had to wait nearly 300 years after its discovery to learn new and interesting details about this moon. In 1944, the eminent astronomer Gerard Cooper made the first interesting discoveries about Titan through his observations. Titan is truly a bizarre moon because it has an atmosphere. Thanks to this discovery, he took a step further and used spectrometry to identify basic materials existing in its atmosphere, discovering methane gas. The 20th century was the era of space exploration, and we have to wait long before newer discoveries about Titan were revealed. The first spacecraft sent into the skies to explore Saturn and its little children was Pioneer 11, which flew past this planet in 1979. Before the first extravehicular landing was conducted, astronomers on Earth already had concrete estimates of Titan's mass and dimensions. This was a chance not only to confirm those estimates, but also to learn more about this satellite. Turns out Titan's diameter reaches 2575 km, larger than our own moon, and amazingly is also larger than Mercury. However, thanks to this finding, we also learned that it is not the solar system's largest moon. Ground-based astronomical observation only shows us its atmosphere shell. And so when looking at it and comparing to Ganymede radius, we thought it was bigger. Additionally, its orbit also has an enormous radius, 1.2 million km from Saturn. Thanks to this flight, humans had the first close-range images taken of Saturn and Titan. In 1980 and 91, the Voyager 1 and 2 duos swept past Saturn, and a new discovery journey began. With their photography systems, we gained clearer views of this giant moon. It is a hazy golden sphere with mysterious bluish illuminations at times reflecting off its atmosphere. In such a distant location with an atmosphere, scientists predicted its shell to consist of liquid methane seas and reflecting the sunlight back into the sky's causal illumination. However, the truth is always more surprising. When Voyager investigated closer, we saw traces of acetylene, ethylene, propane, and other organic molecules, along with abundant nitrogen as the primary component of the pale atmosphere. At a position so far from the Sun, Titan's surface temperature is only -179 degrees Celsius, cold enough for the aforementioned gases to exist in liquid form, flowing like rivers on its surface. This is an environment rather similar to Earth, except the flowing liquid is not water, but organic fluids kept liquefied by the extreme cold. If humans have the need to migrate for a new home, we will have to do quite some work to make the environment habitable, but it is also because of this thought that we pay more attention to this place compared to other moons. In 1990, a Hubble Space Telescope was launched into orbit. In 1984, it had turned to face Titan in order to carry out the mission of exploring this giant moon. Through Hubble's observation, Titan appears as a celestial body with a solid surface. That means it could have an intercore of land and rock enveloped by the odd atmosphere. From there, those unique organic gases found their origin. To explain the agents of this bizarre atmosphere, astronomers theorized about Saturn and Titan having formed in parallel and gaseous planets. Accumulated gases and smaller clumps had not taken shape yet. Those were drawn into larger masses of land and rock like Titan and were eventually manipulated by Saturn's enormous into orbit around itself. Another hypothesis suggests that originally there were larger chunks of materials that accumulated into a terrestrial planet, but after many collisions in space, the fragments scattered and became minor moons. The greatest remaining mass is none other than Titan, which explained how it obtained such a mystifying atmosphere. As mystifying as it was, after years of observation through telescopes and even Phoebes, we could not attain any special discoveries beyond acknowledging its unique atmosphere. In the end, Titan was still just an interesting moon and nothing conclusive. That was the case until we had the decision to land on Titan's surface and bring back more accurate details about this place, which was the duty of Cassini. In 2004, Cassini was launched into space to study Saturn and the mysteries around it. Having a spacecraft orbiting the giant gaseous planet, to study, it was nothing new to astronomers. However, Cassini was designed to carry the latest equipment of the time, along with a gift intended specifically for Titan, the Huygens probe, named after the scientist who discovered Titan. The Huygens probe was ordered to land on Titan on January 14, 2005, becoming the first landing on an extraterrestrial body at the edge of the solar system. Right when it touched Titan's surface, it sent back the first signals to Earth, and astronomers erupted with excitement. Through Titan's lenses, we learned Titan is a place extremely similar to ours, with mountains, rivers, sand dunes, and especially gigantic clouds. These clouds are formed from methane and can create rare concept in the solar system. Evidence of methane rain is erosion patterns on Titan's rock faces. However, those discoveries weren't the most shocking bit. Huygens officially lied. This wasn't enough to assert Titan once contained oceans like Earth's water oceans, but it was enough to raise questions about the existence of oceans on this celestial body. With liquid solutions, there are possibilities for life, although with water on this body frozen, Solid by the extremely cold temperatures, it remains a substance we can hypothesize about and search within for traces of primitive organisms swimming in methane. In short, Titan could contain the answer to the origin of life regarding a primitive Earth we never witnessed. As eager as astronomers were to witness more, connection with the distant land on Titan wasn't solid enough to sustain the investigation. Huygens did not have devices to absorb and store solar energy, thus not extending its lifespan. It only carried enough battery to operate for a certain duration. After nearly 2 hours working on the distant moon, it officially retired and transmitted its final signals back to Mother Cassini to send to Earth. Meanwhile, Cassini would continue orbiting Saturn, capturing the closest images of Titan for humanity until its retirement in 2017, concluding 13 years of working away from home. And so, from 2004 until now, the images from Huygens' perspective in Titan remain the first, and only ones we directly see on Titan's surface. But just hope is more than enough for us to nurture hope for a day we can explore more about this place, which is exactly what we did after Chilean's mission ended. Cassini kept flying around Titan and Saturn to investigate the conditions needed to carry out a new mission. While back on Earth, we continued developing the Dragonfly project to meet demands beyond Huygens' capabilities. Hence, we have Dragonfly, named after the organism that inspired its design. The Dragonfly mission was created to study potential biology on Titan's surface. The reason it was designed based on a dragonfly is because of its wings. This is a complex system utilizing Titan's weak gravity and immense atmosphere to take off and travel to many places on the moon for diversified findings to bring back to the mothership. One issue astronomers and engineers faced when designing Dragonfly was regarding energy. Unlike previous probes whose key operations took place in orbit and didn't consume much energy with its solar panels, Dragonfly could absorb what little sunlight the sun emits from Titan. Not only is Titan so far from the sun that it receives less than one of sunlight if boss, but it is also by its atmosphere. So installing solar panels would not just be inefficient, but also make Dragonfly heavier and harder to take off. However, the solution wasn't as difficult as we imagined, because when we look at how the sun generates energy, there will be a way to save Dragonfly. Dragonfly will carry a nuclear battery light enough for takeoff, yet strong enough to keep Dragonfly running steadily for the expected lifetime of around 10 years. With that battery, Dragonfly can fly up to 100 km, deploy drilling equipment, and bring back more detailed samples to study compared to Huygens. Currently, the tools to be placed on Dragonfly are still undergoing development and refinements before being loaded into the rocket and launched out into space, estimated around June of 2027. That means Dragonfly will land on Titan sometime in the near future, bringing back new findings about the origin of life, ready to dig into the ground, fly, and communicate with life, to reveal more to us about a place that could become home for our film. If that does not sound like a promising mission, then perhaps we need to explore space much more. And that concludes the story about Titan, the moon that could provide life for humans someday. Would you like to explore more about Saturn's other moons? Let us know in the comments below. And if you enjoyed this video, don't forget to like, subscribe to us, and turn on notifications so you won't miss any future videos. Thank you for listening and see you again. Peace.